Good day, welcome to our lesson. We are on week 2, third quarter, patterns and algebra. And for this week lesson, writing rules for sequences. And please don't forget to subscribe Maestro05DX. Before we start, let's have a prayer, a mathematical prayer. Dear Lord, we thank you 100-fold for the love and care that you have given us. May we return to you your good works by multiplying it with love and respect, adding more faith, subtracting the unworthy behavior and evil works, and dividing your given talents to others so that we can sum it all and be united as one in your family. In this we pray. Amen. And for our most essential learning competencies, formulates the rule in finding the n term using different strategies, looking for a pattern, guessing, and checking, working backwards. And for the objectives, at the end of the lesson, each one of you is expected to write the rule for sequence and formulate the rule in finding the n term using different strategies, such as looking for a pattern, guessing and working backwards. Okay, so let's study the month of February. Month of February consists of 28 days. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. Now, so this time let us encircle 4, 8, 12, 16, 20, 24, and 28. Okay, what have you noticed on the encircled number? So the encircled numbers 4, 8, 12, 16, 20, 24, and 28 form a number sequence. And what is a number sequence? A number sequence is a set of numbers written in special order by application of a definite rule. And each number is called a term. Now, if we take any two successive terms of the circled numbers on the calendar, the difference between them is 4. So let me rewrite. So you have the 4, 8, 12, 16, 20, 24, and 28. Now, again, as I've said, let me subtract 4 from 8. And the difference is 4, same as 8 from 12, 12 from 16, 16 from 20, 20 from 24, and 24 from 28. So, the difference is 4. Okay, so let's get now the position of each term. So So you have 1, 2, 3, 4, 5, 6, and 7. So this can be named as M. Therefore, the rule in the sequence 4, 8, 12, 16, 20, 24, 28 is adding 4 to the term before it. So, if we add 4 to the previous term, we will get the next number in the sequence. Okay, numbers, figures, objects, or symbols arranged in a definite order or sequence is often encountered in mathematics. For instance, you have 2, 4, 6. What would be the next possible 3 digits? So that is 8, 10, and 12. Another, for the square, so if you will notice that the color is on the top left, so the next would be on the top right, next would be on the bottom right, and the next is on the bottom left. So perhaps the next would be the whole square will be colored. Next, we have the A, D, G, J. Now, what would be the next possible letter? So that is the M, P, S, and so on. Another, we have 2, 5, 6, 11, and the next 3 digits would be 14, 17, 20, and so on. Next, you have 1, 4, 9, 16, and the possible would be 25, 36, and 49. For the last time, we have 3, 5, 7, 9. And for the next number, 11. And then we have 13, 15, 17, and so on. So if you notice on this example, the 2, 4, 6, we use the skip counting by 2s. And then the figure, we follow the movement of the colors. And then even on the letters, so the interval is 2. And here is 3. Whereas here, if you will notice, from 1 to it becomes 4. And then 3, then 5, the interval is 2. And we will discuss that as we go on how to get the nth term or the rule. Now, let's have a sequence and the next 3. Another example. So you have the y squared, y to the third. So the exponent of the first y is 1, as we all know. So definitely the next would be y to the fourth, and then for the next 3 is, the 3 terms is the y to the fifth, y to the sixth, and y to the 7. Another, you have a, and then 2b, 3c, 4d. So what would be the next? So that would be 5e, 6f, 7g. Another, we have a, then a plus b, Next is A plus 2B. So what would be the next? So that is A plus 3B, A plus 4B, A plus 5B. And then we have the 7A, 5A, 3A. Okay, what would be the next? So that is A, and then negative A, negative 3A. So if you will notice that these are called as sequence. Okay, so this time let us use or to find the nth rule in finding the next number. Okay, so we're going to formulate the rule in finding the nth term for each sequence. And then, of course, we have to use the counting numbers to easily find the rule. Okay, so this is the counting numbers. And then when we say counting numbers, so they are set of real numbers without zero, such as 1, 2, 3, 4, and so on and so forth. Now, let's have an example in getting the nth term. We have 2, 3, 4, 5. So this is a sequence. 2, 3, 4, and 5. And 2, 3, 4, and 5, we call this as the terms. So let n be represent a counting number, and the nth rule for the sequence is n plus 1. So why is it n plus 1? This is just a preview of what we are going to discuss as we go on. Okay, so considering that the first term, the position of 2 is 1, so 1 stands for the n. The 1 plus 1 is 2, so we got the first term. And then n is 2 plus 1 is 3. N is 3 plus 1 is 4. And then n is 4 plus 1 is 5. That's why this is 2, 3, 4, and 5. Again, n stands for the number of terms. Okay, to redefine again sequence, it is a set of numbers written in a special order by application of a definite rule. Again, as I've said a while ago, each number in the sequence is called as term. Okay, so to go further to our lesson, look some patterns or rules that will help you to continue a given sequence of numbers or fill the missing numbers or symbols. So again, let's say we have the sequence of 3, 6, 9, 12. And we're looking for the next 3 terms. Now, we are now moving on the how to find the nth term. Now, so let's get the position of the digit in the sequence. So 3 is 1. Of course, 6 is 2. Then 9 is 3. 12 is 4. And the next succeeding would be 5, 6, and 7. Now, if you will notice that if we are going to subtract 3 from 6, the difference is 3. And then 6 from 9, the difference is 3. So therefore, to write for the n, for the nth rule, so that is the 3, 3, and 3. And if you will notice that the common difference is 3. And then the 1, 2, 3, 4, 5, 6 stands for the n. So that is how to get the nth rule. So 3 is the difference. And then we have the n. Okay, now, why is it 3n? So meaning that is 3 times n. So let's substitute. If n is equals to 1, then 3 times 1 is equals to 3. So if you will notice that here 3 times 1 is 3. So we check we are correct on the first term. Now let's check for the second term. So n is 2, 3 times 2, 6. So this is also correct. Then 3, the n is 3. So 3 times 3 is 9. And then correct again. And then 3 times 4 is 12. So therefore, the rule is 3n. And to get the value of the fifth term, just multiply 3. So that is correct. Just is multiply 3 times 5. And that is equals to 15. 3 times 6 is 18. And the 3 times 7 is 21. Again, if you'll notice that even you subtract 12 from 15, the difference is 3. 15 from 18, the difference is still 3. And 18 from 21 is still 3. So, therefore, the common difference is 3. Okay, next. So, we have the sequence 1, 4, 9, 16, and then looks for the next number, the next 3. Now, if you will notice, if we're going to get the position of each digit, so that is 1. 1 is for 1, 4 is 2, 3 is, 9 is 3, and then 4, 5, 6, 7. Okay, so getting the n, we can multiply it by 1. So 1 times 1 is 1. So if you notice that if we multiply 1 by itself, the result is 1. And 2 multiplied by 2 is 4. And 3 by itself is 9. 4 by itself is 16. So therefore, 5 times 5 is 25. And okay, so I'm just repeating it. 5 times 5, 25. 6 times 6 is 36, and 7 times 7 is 49. Therefore, the rule is we multiply the counting numbers by itself or squaring counting numbers. Therefore, the nth term is the n squared. Okay, another sample. You have 3. 1, negative 1, negative 3, and then looking for the next 3 digits. If you notice that this is in descending order. So from 3 to 1 to negative 1 to negative 3. So if we're going to subtract this, the result will be like this. Okay, now, so let's get the position first of each digit. So it stands for n. So this is 1, 2, 3, 4. And the position of the unknown 4, 5, 6, and 7. So since we are looking for the nth term or the nth rule, so get the difference. So that is negative 2. 1 minus 3 is negative 2. Negative 1 minus 1 is negative 2. Then negative 3 minus negative 1 is 2. And so on. Now, so the common difference now is 2. Take note that the common difference is 2. And then we are looking for the next digit. So that is to multiply it by n. Now, if you're going to check, if n is 1, negative 2 times 1 is negative 2. So meaning, we're not able to satisfy the first term. So negative 2 times 1 is negative 2. So what are we going to do to satisfy that the first term is 3? So are we going to add or subtract? So that is wrong. So again, so we have to put 5. Where does 5 came from? So we add 3 from 2. Disregard first the sign of the difference. 3 plus 5, 3 plus 2 is 5. And then subtract by 2n, which is the common difference and the number, the position of the sequence. Okay, so let's check if we can be able to satisfy the first term. So that is 5 minus 2n is our nth rule. So 5 minus 2, the position of 3 is 1, times 2 is negative 2, and then 5 minus 2 is 3. So we're able to get the first term, which is 3. Next, we have 5 minus 2 times 5, that is 5 minus 10. Now, this is the first term, and then we are looking for the fifth term. So that is negative 5. And then for the sixth term, we have 5 minus 2 times 6. That is equals to 5 minus 12 is equals to negative 7. And for the seventh term, we have 5 minus 2 times 7 is equals to 5 minus 14 is equals to negative 9. Okay, so again, if you're going to get the difference of 5 and 3, 5, negative 5 and negative 3, that's negative 2. And then negative 7 and negative 5 is negative 2. Same as negative 9 and negative 7, the difference is negative 2. So the nth rule is 5 minus 2n. So this time, let me make a table. Okay, and there are the number of terms. We have the sequence. Okay, the sequence are 7, 11, 15, 19. So we are looking for the next 3 digit, and let's position this. So 1, 2, 3, 4, 5, 6, 7. Now, considering that we are looking for the 57th term. We are looking for the 57th term. Okay, so let's get the common difference of 7 and the difference of 11 and 7 is 4. 15 and 11 is 4. 15 and 19 is 4. And the next number would be 4. So, again, their common difference is equals to 4. So, since the common difference is 4, so we can bring down the 4 to start with the nth rule. And then, since the first term is 7, so let's put the n. Okay, so if you will notice that the 4 times n, if you're going to substitute the value of n as 1, 4 times 1 is 4. So we didn't satisfy 7. So what shall we do to be able to get 7? Are we going to add or subtract? So then, just to show you that 4 times 1 is equals to 4. So that is wrong. So therefore, the 4n must be added by a constant number. And what do you think is the constant number for us to get 7? So let's add 4n plus 3. Okay, now to check. 4 times 1 is 4 plus 3 is 7. Okay, so we are able to satisfy the first term. How about for the second term? If n is 2. So 4 times 2 is 8 plus 3 is 11. For the third term, 4 times 3 is 12 plus 3 is 15. And then for the fourth term, we have 4 times 4 is 16 plus 3 is 19. Okay, so therefore for the fifth term, we have 4 times 5, that is 23. So the fifth term is 23. And then for the sixth term, we have 4 times 6 is 24 plus 3 is 27. And for the seventh term, we have 4 times 7 is 28 plus 3 is 31. So this time, let's get the 57th term. So, just multiply 4 multiply by 57. Then add 3. And 4 multiplied by 57 is equals to 228 plus 3. Therefore, the 57th term in the sequence is 231. Okay, next. Okay, number of terms or the position, the sequence, the 3, 6, 9, 12. Okay, so we're looking for the next 3-digit and the position. 1, 2, 3, 4, 5, 6, 7. And we have to get also the 43rd term. And let's get the common difference. The common difference, 6 minus 3 is 3. So they're all 3. So to find for the nth rule, so since the common difference is 3, so you have to write 3. And then we have the n. So you have already the 3n. Okay, so let's check. If n is 1, then that is equals to 3 times 1 is equals to 3. Is the nth rule correct? The 3n? Yes, that is correct. Because if we're going to substitute the value of the position rather of the second term, that is 2. So 3 times 2 is 6. And for the third term, that is 3 times 3 is 9. So therefore, to get for the value of the fifth term, just multiply 3 multiply by 5, and that is equals to 15. And then for the sixth term, so that is 3 times 6, which is 18. And for the seventh term, 3 times 7 is 21. So since we're looking for the 43rd, just multiply 3 by 43 to get the 43rd term in the sequence. So the 43rd is 129. Why is it 129? We multiply 3 by 43, and 3 times 3 is 9, and 3 times 4 is 12. That's why the 43rd term is 129. More example. Number of terms. Then you have the sequence 6, 9, 12, 15, 18. And look for the next 3 succeeding. Okay, so we have the position of the sequence 1, 2, 3, 4, 5, 6, 7, and let's get the 104th term. Okay, so let's get first the common difference. The common difference of 6 and 9 is 3, 9 and 12 is 3, 12 and 15 is 3, 12, 15 and 18 is 3, and the next number is 3. So since the common difference is 3, therefore the nth rule is 3, which is the common difference, and then multiply it by the n. Now let's try to check if we can be able to get 6. So again, if n is 1, 3 times 1 is 3. So is the equation correct, or is the nth rule correct? So that is wrong. Why? Because we have to get the first term, which is 6. So therefore, the 3n has to be added by another number to get 6. So let's try to add 3 to the formula. So we have 3n plus 3 will become, to solve, so we have 3 times 1 plus 3 is equals to 6. So we satisfy the first term. Now, let's check the second term if it is correct. The n is 2, 3 times 2 is 6, plus 3 is 9, and then 3 times 3, 9, plus 3 is 12. So, therefore, the rule is 3n plus 3 So that is the rule. Okay, so this time let's find for the 6th term to 104th term. Okay, so that is 3 times 6 plus 3 is equals to 21. 3 times 6 is 18 plus 3 is 21. And for the 7th term, so that is 3 times 7 is 21 plus 3 is 24. So same procedure to get the 104th term. Multiply 3 by 104 and then add 3. So 3 times 104 is 312 plus 3 is equals to 315. So 315 is the 104th term. Okay, so using the end rule, we are not going to multiply a too long number, just the position of the number to get the number in a sequence. Okay, more example. So we have the number of turns, the sequence, and the sequence are 60. So this time we are on decreasing 60, 48, 42, and then looking for the number and even on the last or the end term. So let's get the position of each term. So we have 1, 2, 3, 4, 5, 6, 7, and let's get the 19th term. Now get the common difference. The common difference, 54 minus 60 is negative 6. 48 minus 54 is negative 6. 42 minus 48 is negative 6. And whatever number is there, so the difference is 6. Now, to get the nth rule, so since the common difference is 6, so write 6 and then the n. Now, so we have the negative 6n. To check, negative 6 times 1 is equals to negative 6. So, the 6n is not yet correct. So, we have to add numbers to be able to get the 60. So, let's try to add 6 and 60. So, 60 plus 6 is 66. So, therefore, negative 6n added by 66. Okay, to substitute, we have 6 times 1 is negative 6 plus 6 is equals to 60 or positive 60. Let's check for the second term if 66 is the constant number. So negative 6 times 2 is 12 plus 66 is equals to 12. Negative 12 plus 66 is 54. So that is correct. How about for the third? You have negative 6 times 3 plus 66 is equals to negative 18 plus 6 is 48, correct? And then negative 6 times 4, the fourth position, plus 66 is equals to negative 24 plus 66 is equals to 42. So this time, let's get the fifth term. So negative 6 times 5 plus 66. So that is negative 30 plus 66 is 36. For the sixth term, you have negative 6 times 6 plus 66 is 36 plus 66. So the sixth term is 30. Now for the seventh term, we have negative 6 times 7 plus 66 is 42 plus 66 is 24. Now, what if we are looking for the 19th term? So, just multiply negative 6 by 19, then add 66. So, negative 6 times 19 is equals to 140 negative plus 66 is equals to negative 48. So, negative 48 is the 19th term in the sequence. So, this time, let's use the fraction. So, we have 1/2, 1/3, 1/4, 1/5, and then look for the next digit or fraction. Let's get the position of the sequence, and then let's get the 54th term. Let's get the difference if they have the common difference. Common difference is 1. So, since the common difference is 1, and our n term will become n plus, but it is a fraction. So, we have to add n plus 1 over 1. So, our numerator is 1 over n plus 1. So, let's check. If n is 1, 1, so you have 1 over 1 plus 1 is 1/2. Next, we have the 2, then 1/2, 1 over 1 plus 2, so that is 1/3. So we are just now we are now on the 6th term. 6 plus 1 over 1. Take note that n is in the denominator, not on the numerator. You might be wondering why we can add whole number since the n is. Take note that n is in the denominator. That's why you can get the 1/7. And then the 7th term is 1/8. And of course, the 54th term, so that is, just add the 54 to so the 54th term is equals to 1 over 55. Okay, last sample. Sequence 142, 442, 942, 2542. Then we have the number of terms. And let's get the 15th term. And then we have the common difference. What is the common difference? If you will notice, they don't have common difference, the denominator. So since they have the same denominator, so they have the same denominator. So therefore, in this case, if you will notice that, just I'm looking, this is 1, 4, 9, 16, 25. We will just double or square the n. So that is n square. And then write the denominator as 42. So that is equals to 1 squared over 42 is equals to 1 over 42. Same as 2 squared over 42 will become 4 over 42. Then we have This is 9, not 6. 9. So this time, let's get the 6th term. So this is the 6 squared over 42. That will become 36 over 42. And for the 7th term, 7 squared over 42 is 49, 42. And for the 15th term, so that is 15 squared over 42. So therefore, the 15th term is equivalent to 225 over 42. Okay, so complete the pattern. Let me guide you. So you have the sequence is 14, 17, 20. Get the common difference. Of course, n. So the rule is 3n. So that then plus 11. Because if that is only the 3n, 3 times 1 is 3. You cannot get 14. Therefore, 3n plus 11 will become 3 plus 1 is 3 plus 11 is 14. So, for the second term, 3 times 2 plus 11 is 17. And then for the third is 20. So the terms are 23, 26, and 29. Okay, so another method of solving this, instead of starting from 1 as our n, so let's use other number. But the same given, so we have the series are 14, 17, 20, and we are looking for the next. So they have the same given number, but it will differ only on the position of the number. So let's start from 5. So 5, 6, 7, 8, 9, and 10. And then the common difference still 3. So since the difference is 3, so let's write 3 for the rule, and let's check. If n is 5, 3 times 1 is 15, but this is 14. So what shall we do to get 14? What shall we do to get 14? Yes, very good. We have to subtract 1. That's why this is trial and error or moving. You can solve it backwards or next we have. So therefore 3n minus 1 is the rule. You can check. 3 times 5 is 50 minus 1 is 14. And then 3 times 6 is 18 minus 1, that is 18 minus 17. And then 3 times 7 is 21 minus 1 is 20. So same. So you can be able to get the next 3 digit. So 3 times 8, 24 minus 1 is 23. So we have the 23, 26, and 29. And for your activity, find the next 3 terms in each sequence, but be sure to write the nth rule or the rule. Don't just write the number. Again, don't just write the number, just give the rule. So you have 10, 15, 20, 30. Find the next 3. Number 2, 3, 5, 7. Then number 3, 20, 16, 12, 8 is this decreasing order. Then number 4, you have negative 8, negative 10, negative 12. And for number 5, you have 4, 11, 18, 25. Then look for the next 3 numbers. And you have to look for the rule. And that's it. Thank you for watching. And don't forget to click and subscribe. Okay, thank you and have a good day.